Here we have a SAT math problem. Okay, let's cover the question. In the xy plane above, line L is tangent to the graph of circle O and the value of sine angle ORP is 0.6. If the area of triangle OPR is 54, what is the radius of the circle? Okay, in the given figure, we have to get the radius of the circle. Okay, now let me draw a radius to this circle by connecting the center of the circle O and the point Q on the circle. Okay, here the Q is the point of tangency. That is, at the point Q, line L is tangent to the circle. At the point of tangency, always the angle between the radius and the tangent line is a right angle. Okay, here we have to get the length of this line segment OQ, which represents the radius of the circle. Now, let me consider the triangle OPR over here. In this triangle, what is the angle we have at the vertex O over here? So we have right angle because so this is a point at where the x-axis and y-axis intersect. In any xy plane, always the x-axis and y-axis will intersect at right angle. So this OPR is a right triangle. Okay, in this right triangle, we have the value for sine of angle ORP, that is 0.6. So angle ORP is over here, this interior angle. ORP is over here. For this interior angle, we have the value for the trigonometric ratio sign, that is 0.6. Okay, now let me write the stuff over here. That is sine of angle ORP equals to 0.6. And we can write this decimal value as a fraction, that is 6 over 10. And here 2 goes into 6 3 times and 2 goes into 10 5 times. I am getting 3 over 5 as a value for sine ORP. That is, I have written this 0.6 as a fraction 3 over 5. According to Staccato, the formula for the trigonometric ratio sine is opposite side divided by hypotenuse. Okay, now in this right triangle OPR, for this interior angle ORP, the side OP which is opposite to this angle is considered as opposite side, and the side which is opposite to the right angle over here is called hypotenuse, and the name of the third leg is called adjacent side. Okay, here this number 3 is corresponding to opposite side and this number 5 is corresponding to hypotenuse. Okay, from these two numbers 3 and 5, if I want to get the actual length of the opposite side and the actual length of the hypotenuse, I have to multiply these two numbers by the same non-zero number, say x. That is, when I multiply this 3 by x, I am getting 3x. This 3x is the actual length of the opposite side. When I multiply this 5 by the same non-zero number x, I am getting 5x. This 5x is the actual length of the hypotenuse. Okay, here I got the length of the hypotenuse, that is 5x, and also I got the length of the opposite side, that is 3x. Actually, it's a 3, 4, 5 right triangle over here, this OPR, because the length of the hypotenuse is 5x, and in the remaining two legs, the length of one of the legs is 3x. Then the length of the other leg OR must be 4x. So because it's a 3, 4, 5 right triangle. And for this right triangle OPR over here, we can consider this OR as the base and this OP as the height, because this OP and OR are perpendicular. So we can consider the horizontal line segment as base and vertical line segment over here as height. And we have the area for this triangle OPR in the given information, that is 54. Okay, now let me write the stuff over here. Area of triangle OPR equals to 54. And we have formula to get area of a triangle, that is base times height divided by 2 equals to 54. Okay, now we can plug in a value for B over here, that is base and height. So we know that this 4x represents the base of the triangle and this 3x represents the height of the triangle. So we can plug in this 4x for base and 3x for height over here. Let me plug in, then we get 2 equals to 54. Okay, here 2 goes into 2 1 times and 2 goes into 4 2 times. Okay, so when I multiply this 2 and 3, I am getting 6. X times x is x square. I am getting 6x square equals to 54. Okay, now let me divide both sides of this equation by 6. Then this 6 will cancel out. I am getting x square equals to 54 divided by 6 is 9. Okay, now to solve for x in this equation, I have to get rid of the exponent 2 over here. For that, we have to take square root on both sides of this equation. Then the square root and square will cancel out. I am getting x on the left side. When we take square root on both sides of the equation, usually we consider positive or negative sign for the square root we have over here. But here, I don't consider positive or negative sign. I consider only positive sign for the square root. If I consider negative sign for the square root, then the value of this x will become negative. Then the value of this 4x will be negative and 3x will be negative. That is, the length of the size of the triangle will become negative. That is not possible. So we can consider only positive sign for the square root, and square root of 9 is 3. Okay, here I got the value of x, that is x equals to 3. Now let me plug in x equals to 3 into this 5x, then I'll be getting the length of this hypotenuse sphere of this right triangle OPR. So 5 times 3 is 15. So 15 is the length of the hypotenuse of this triangle PR. Okay, and also let's consider the line segment we have over here, OQ, which represents the radius of the circle. Actually, this line segment has been drawn from one of the vertices of the triangle O to the opposite side PR of this triangle. And also, this line segment OQ is perpendicular to the side PR of the triangle. Clearly, this line segment OQ represents the height of this triangle. So in that case, we can consider this side PR as the base of the triangle. Okay, now for the same right triangle OPR, OQ is the height and this PR is the base. Okay, with this height and base, we can get the area of the triangle. But already we have the area of the triangle. Okay, let me write the stuff over here. Area of triangle OPR equals to 54, it's given. And the formula is the same formula, base times height divided by 2 equals to 54. Okay, now let me consider the side PR of the triangle as base and this OQ as a height. Already we have the base, that is the length of the side PR of the triangle, that is 15. We can plug in this 15 for base of the triangle over here, then 15 times. So this OQ is the height of the triangle. We can plug in OQ for H over here, that is 15 times OQ divided by 2 equals to 54. Okay, now let me multiply both sides of this equation by 2. Let me do it. Then this 2 will cancel out and 15 times OQ equals to, on the right side, when I multiply 54 and 2, I am getting 108. Okay, now to solve for OQ, let me divide both sides of this equation by 15. When I do so, this 15 will cancel out. I am getting OQ on the left side. On the right side, when I divide 108 by 15, I am getting 7.2. Actually, this OQ represents the radius of the circle. So the radius of the circle is 7.2 units.